Right. Hi guys. Good good evening everyone. Let's start this session. Let me just check my writing pad here. Okay. Uh let's start this session. So thanks again. Thanks everyone for joining in this class. My name is Akash. Let's start with basic understanding of myself and then we will go ahead further in this session. I will also have a quick understanding of you guys as well, as you guys will basically tell me what's there in the chat. So thanks again. Thanks everyone for joining this session. My name is Akash, and I will be actually talking about, uh, you know, I will be talking about the data science and AI stuff, right? So this masterclass is going to be, this masterclass is going to be how do we use artificial intelligence in analytics. So we are going to see what exactly is analytics, and then how are we going to use it in the how are we going to use this in the with the help of AI, right? So we are also going to see what exactly is artificial intelligence. Then we are going to see what is analytics, and then we are going to see how can we use the artificial intelligence that is available today and make it done in the with the help of AI. All right. So let's start with myself first. My name is Akash, and I have been working with the industry approximately 6 years, 6 plus years. I have been working. I have already, in previous, I have worked with Cognizant as a data science, as a data engineer. Then I worked for Deloitte as a data science consultant. Currently, I'm working as a machine learning engineer, senior machine learning engineer with Nagaro, and I interact with a lot of data. And I use, artificial intelligence. I use the machine learning and all the other different subsets of AI to actually transform that into real insights that businesses can use. Okay. Uh, before uh, before I start with this, Before I start with this, I'm going to ask you guys a question. The simple one is basically whether or not you guys, how many of you guys are, working professional in this class, and how many of you are, students? Just simply, if you are a working student, just put student in the chat section. If you are a working professional, just put a working professional in this chat. I'll have a quick look and then, I'll have an idea what kind of peoples are there in this class. Okay, working professional, both student, freelancer, student also. All right, great. I can see majority of the people here in this class are students. That's great. Yeah, let's. There are some other messages. Okay, okay. So I'm assuming majority of the students, like 90% of the students in this class are uh, students, right? 90% of people in this webinar are students. So let's start. I'm gonna actually start it from the very beginning. I'm not gonna go the advanced portion in this one. So I'm gonna start it from the very beginning. And let me just write it here. Just give me 1 second. Okay, so we are going to see how can we leverage AI in data analytics and how do we combine actually AI and data analytics and we call it a data science. We are also going to see the roadmap. We are also going to see the data science pipeline as well into this one. Okay, so first off, let's start with what is artificial intelligence in the first place, right? So artificial intelligence. So if I ask you guys a question, what is AI? Can anyone tell me specifically about AI? What is artificial intelligence in the first place? I would expect some answers from you guys. Okay, mixing machine artificially intelligent mimicking human natural pathways. AI helps to ease the work reducing the human intervention. Dhanlakshmi, your answer is kind of an application of artificial intelligence, but not the definition of like that could be one of the application to actually ease. And I mean that not could be, but that is one of the application to ease the human intervention. Uh, but not an example, I would say, not a definition, I would say. But anyways, the first one, Hishika Sharma says, making machine artificially intelligent by mimicking human pathways, human neural pathways. That is a good answer. Human intelligence in machine. Yes, that is one of the best answer that we can get. Anyways, let's start understanding. So if you see by the name itself, it has two things, A and I. So the first thing that says artificial, okay, and then intelligence. Now, if there is something that is artificial and that is intelligent, that we can call an artificial intelligence. So now let's understand what exactly is artificial and what is intelligence. Artificial means something that is not natural, not natural or made by humans. And we can simply say that that is an artificial thing, right? If it is made by nature, it is some other organism. If it is some, anything that is made by nature, we can call it a natural thing, right? If that is made by us, we can call it human made or artificial, right? For example, there is a very good example of artificial and natural. That is with diamonds. Diamonds are found in the nature as well. That takes billions of years to actually compress and form diamonds. And on the other hand, you can also create diamonds in the lab by applying immense amount of pressure and doing using that in a controlled experiment lab. So diamonds are a very good example of being natural and artificial. Simulation of human intelligence by machine. AI is the simulation of human intelligence machines, enabling them to learn, reason, make decisions. That is a good answer. Yeah. And now, what is intelligence? If you see, intelligent is nothing but ability to think, ability to reason, ask questions, give answers, take decisions like this. So, if let's say if there is an artificial machine that has ability to think regions, take decisions, give the answer, ask the questions, if it has these kind of abilities, we can call it that an artificial intelligence, right? Now artificial intelligence has different types of two different types of uh, I would say partitions. So the first one, AI can be uh, classified into two ways, not two types, but two ways. The first one is basically, I mean, a narrow AI, and then we can call it AGI and super AI. So far we have only built narrow AI. So let's say I'm building a model to predict or to forecast the stock market. If I'm building the model to forecast the temperature, the weather, or you know, let's say the prediction of breast cancer, house price predictions, and all of this. So these are nothing but a very narrow AI, right? We just apply that into a very narrow field, and that can only work in that field. The AI cannot go and work into some other interconnecting field as well. It cannot work into that. Let's say if I have built a model to predict the breast cancer, I cannot use that model to forecast the stock market, right? I cannot use that model to predict anything other than, cancer and non-cancer thing like that. Even if I change the data, it will not work. So that basically you can think of narrow AI that has been developed with a sample of narrow data, and it would only work into that particular field. Now, artificial general intelligence is the kind of something that is in progress. Even ChatGPT is not, you know, AGI so far. They are building the AGI. You might have heard there is a name called Baby AGI. People are building kind of an AGI multi-model capabilities. Some of the uh, LLMs that has multi-model capabilities, and they are able to actually do some of the tasks, but not efficiently, and that's why they are calling it baby AGI. Okay, so AGI is basically something that has ability to do all the general tasks as humans do, right? So, for example, if I talk about general tasks such as cooking the food, driving the car, going outside, doing the laundry, like literally anything, right? You can think of anything if an artificial intelligence has an ability to do literally anything that one human can do, right? So we can call it an artificial general intelligence that can perform all the general tasks that a humans can do. And obviously, if it is a machine, then it will have ability to do it better and faster. All right. Maybe faster for sure. Maybe not better, but faster for sure. Okay. Now that is called AGI. AGI that has ability to do some general tasks. Super AI is kind of can literally do anything. Can do anything. Anything by means anything. So, for example, you might have heard about um the movies such as Terminator or Age of Ultron. So these are nothing but the artificial general. I mean, super AI, right? These are super AI. They can literally do anything. They can create their own versions, and this is where we don't want our society to go into. This is the condition where we don't want to go. Now, so this is one type of classification of artificial intelligence. Then there's another type of classification that we can do that is called uh, knowledge-based AI. And then we have data-driven AI. Okay. There is this another type of classification that we can do within AI. There are two types of classification. There is this knowledge-based AI and the data-driven AI. What is the difference between these two? Knowledge-based AI is basically it's kind of we actually train the models. We actually build the algorithms to work for a specific cases. All right. So, for example, you might have heard about searching problem. Searching problems basically we find the solution by searching for the solutions, right? So we have different methods. We have BFS, DFS. These are nothing but simple, uh, you know, uh, I would say deterministic algorithms. Uh, but these are rule-based algorithms. But if you add a little bit of heuristic, we can call it an artificial intelligence. So if you are in a, in your terms in a, let's say BTech or somewhere, and you're learning about the AI, you might have got about something A star search, heuristic search, right? So these can be thought of as a knowledge-based AI. So where we try to solve problems such as, traveling salesman problem, route traversal optimizations, right? um trying to find the fastest route using Digextras and all that. So we can simply classify them into problem solving agents, and we can call them a knowledge based AI because we actually do that coding, do that make that agents only for a specific purposes or a task, right? You can also put that into the group of narrow AI. Basically, data-driven AI also comes into narrow AI as well, but this is also into narrow AI. Now, the data-driven AI comes where you train the model based on the data that you have, right? So, for example, if I talk about data-driven AI, so literally anything that we are using so far, all the things comes into this data-driven AI, right? So like ChatGPT, building a simple neural network model, uh, to read the scans, the medical scans, MRI, predicting the surgery, predicting the cancerous tumors and everything. Literally, that is a data-driven AI. So we first train the data based on that. We first train the model based on the data. We will give the inputs and outputs, and the model is going to understand the underlying patterns into that connects the input to the output. And then when you give the fresh data, it will actually do the same task on that. And whatever results based on that it will give, it will be able to produce the result. So that we can think of as a data-driven AI, right? Now, let's say data-driven AI is basically, you might have heard about the terms such as machine learning, artificial intelligence, machine learning, data science, deep learning, data engineering, everything, data analytics, right? So let's start understanding what's the pattern, what's the difference between these, things, and how can we actually understand these whole things in understanding with the help of a Venn diagram. Right. So think about artificial intelligence as a simple universal set, right? Artificial intelligence as a simple universal set. Now, machine learning can be thought of as the subset of artificial intelligence, right? Machine learning is basically nothing but a subset of artificial intelligence, subset of AI. And most of the thing that is being developed right now is being developed with the help of machine learning itself. As I told you, there are some other um, such as knowledge-based AI, I would say. Machine learning you can think of as a data-driven AI, and this is knowledge-based AI, right? This is data-driven. Okay. Now, machine learning is basically most of the people, when I was asking the question, what is artificial intelligence? You guys were, people tend to tell that when we train the machines with the help of data and they mimic human behaviors. So most of the people tend to actually tell the definition of machine learning, right? So machine learning is basically when we make the machine learn with the help of data without being explicitly programmed for it, right? When I say without being explicitly programmed, that means if I'm, let's say, creating a machine learning to add numbers, I will not simply put the formulas, let's say, function to add two numbers, right? So, for example, there's a difference between this. Remember that. So let's say if I'm creating an ML model to add two numbers a comma b, and the output is going to be a plus b, right? I will not simply write the function that will take two numbers and add them together and give the result, because that is a rule-based task. And I also come to the question that we do not actually solve rule-based task with the help of AI, with the help of machine learning. We do not do that. Let's try to understand without being explicitly programmed, what does it mean? When I am actually writing a function to take two inputs and convert them into the summation of this is called programming. I mean, I'm explicitly programming it to add two numbers. But when I'm talking about machine learning to add two numbers, I will not program it, but I will show multiple examples of this, right? So let's say 3 comma 5 gives us the result 8, right? Similarly, I will give multiple examples, 3 comma 9, give me the result 11, 7 comma 9, give me the result 16. So such multiple examples I will give, and that is why, and then let's say I give millions of examples, and then even then I cannot be sure that it is going to give me the correct results. And this is the reason we do not do rule-based tasks with the help of machine learning. What do I mean that? I mean by this that when you have a fixed rule-based task that you can simply do by defining the rules, you should not do that with the help of AI. There are some machine learnable tasks. There are, the thing that you cannot describe in the rules that can be done with the artificial intelligence, right? Let me just give an example. Um, let's say driving the car is could be one of the example where you can see people, artificial intelligence, like there are multiple AIs people are building that will be able to drive the car, right? Now, um, there are although some rules to drive the car, there are some traffic rules for sure that you can encode, but even then, by encoding these rules, the car cannot drive by itself. Doesn't mean if there is a green line, then you should keep going. There are all rounds of all different other scenarios that you have to take care of, right? You cannot code that. You cannot write the code, the conditions to actually assess the scenario, and then how fast you should go, where should you go, and all of that. You can plan the path, obviously, with the help of deterministic rule-based systems. You can, there are some other rule-based systems to stop, to go, where to stop, and all of that. But you cannot actually program it to actually drive it. Even though if you apply all the rules and everything, your model will not be able to drive. For example, if I give you, if you have never driven a car, and if I tell you all the traffic rules, you will not be able to drive that for sure, right? Because you need experience. You need to learn driving first, right? So that is why this is where machine learning comes into the play. So you will actually train that model based on multiple immense amount of data. That's why human drives and the sensor collect the data, and then later on those data will be used to train, right? So for example, when this situation happened, then what did the driver do? When that situation happened, then what did the driver do? And all of that. So those will go into the model, and then model will learn. So if I talk about the machine learning, the black box analogy, uh, people only explain machine learning with the help of this black box analogy. So you can think about this machine. Let's say these are the inputs. input data, output data. So we will give this data into this, and then it will try to understand the rule behind it, right? If I talk about classical programming is a little bit different. Classical programming is kind of where you give the input, and you give the rule, and it will give you the output. But in this case, we will give the input, we will give the output, right, as an example, and then it will try to find out the rule behind that. So, for example, this example I told you, right? So we will give 7, we will give, 7 comma 2, and we will give 9 here, right? So I'm giving 7 comma 2 as an input data, 9 as an output data, and then it will try to find out what's the rule behind it. So it will eventually understand this is summation. And when you later on give inputs such as 8 comma 2, then it will give the result as 10. Maybe not exactly 10, but somewhere close to 10, because that is how machine learning behaves. Right. So this is this is called machine learning, right? This is what we how we understand a simple machine learning. Google Maps is categorized as a, first of all, Google Maps is not an artificial intelligence. Path planning, finding the shortest route, Dijistra's algorithm is knowledge based, right? These are the fixed rule based algorithm. These are not any AI in the first place, right? So everything happens based on the real time data. That is a very good example of you know processing real time data. Now let's come to machine learning. So machine learning has some of the probabilistic algorithms, statistical algorithm, probability, stats, right? And other than that, we also have something called deep learning, DL, right? So other than the subset of machine learning is basically deep learning as well. So we can understand deep learning as where we actually try to build human mimicking machines. So we try to mimic how exactly human brain works, building artificial neural networks. So if you see, artificial neural network is basically something that uh, that we try to mimic how exactly human brain works. So we have neurons in our head, and based on the certain input and output, it will fire, right? It will give the response. So we will try to encode the same thing using artificial neural network. And I would say today, 99% of the development task is basically happening in the artificial neural network cases, right? The probability, statistics, these are being used a little bit lesser as compared to the artificial intelligence. As compared to the artificial neural networks, that is because they tend to work really, really good in literally all the conditions, right? So this is about ML, AI, and all. This is about the categorization between AI, ML, and deep learning. Now there are some other terms as well. Let's come to that. Before that, let me just quickly start with um, the different types of ML first. So in the ML, uh, before that, let's understand the analytics first. What is analytics in the first place, right? Then we will basically understanding this. So data analytics or analytics is basically nothing but uh, getting the data. So data analytics involve examining the raw data to uncover the patterns, the conclusions, draw conclusions, and take the data, and support your decision making. So whatever decision that you are going to take, you can help your decisions based on the data that you have got, right? So there are few key components of the data analysis. The first thing is the data collection. the first thing, now that we have understood AI, I'll join these both the things together as well, the data analytics and AI. And before that, let's understand the data analytics first, right? So, um, as I told you, data analytics basically involves examining the raw data to uncover the patterns and conditions, and draw the conclusions to support your decision making, basically. Anup Pandey has raised a hand. Do you have any question, Anup? You can simply put the question in the chat section. I will see that. Okay. All right. So, see, what is data collection? Data collection is basically, or we can also call it a data mining, gathering the data from various sources. It could be databases, it could be APIs, it could be different IoT devices, Internet of Things, sensors, right? Um, with the help of surveys, right? You can roll out surveys. People can fill the form and survey data. So there are multiple ways of collecting the data, right? So data collection is a very crucial thing. Data collection or data mining, we can also call it. So most of the time when you're doing the analytics, you will get the data already. You will get the data, right? Most of the time, as I told you, 90% or 80% of the time you will get the data. But rest assured, um, rest 20% of the time, less 10% of the time, you will have the problem statement, right? Why? Because company will hire you having a problem. They will tell you the problem, and then you will give the solution. And in giving the solution, you will ask them, "This is the data I need." And when they will give you the corresponding accesses to the databases or some other ways if you want to roll out surveys and all that. So I would try to recall my one of the project when I was in Deloitte. So when company came to us and asked that we have a problem of churning. Churning is basically nothing but where the employee leaves. I mean, without telling them anything, right? They don't know why the people are leaving, right? So what we actually did, we asked them what kind of data you have for us. So we onboarded them as our client. We listened their concern. So they had a question. The question was why the employees are leaving to themselves, leaving the company, right? So we actually went ahead and found the data set at multiple different places, such as Indeed, such as Glassdoor, the company reviews data. We also got the access to the data. So whenever an employee leaves, they give exit survey, right? We roll out. Every company almost roll out exit survey data. They actually fill the form and tell different aspects of their careers, right? Most of the people were telling that they are going ahead for a better future, better career. But that was actually not the case, right? People try to be polite. So what we did, we combined these two data sources and did an analysis. Basically, Deloitte had a very good framework of analyzing the data based on different, I would say, different pillars, right? So they had a pillar of agility, innovation, learning, management. So so we used natural language processing and we used large language models to actually analyze the data and score them. They had a very sophisticated framework and give them score on each pillars, right? So based on that, there will be a score, right, on the management part, on the learning part, on the innovation part, right? So there will be different scores on each pillars, and then you can see which pillar of yours is not working good. And definitely these pillars can be changed as well. Every pillar, there is a definition for that pillar, um, and there will be key keywords for them. So we actually use generative AI to match them together and find out how many comments are there corresponding to this pillar, and then based on that, if the comment is positive or negative, we give them the score, right? So that is one of the example of data analysis, right? Now we used AI where to actually give them the sentiment to each comment and each comment categorizes to what pillar, and then we have a formula to actually give them the score. We call it a net promoter score, and then we have a final score accommodating, like taking the average of all these five, either the simple average or the weighted average you can take to all of these five different components, five different pillars. There can be more than five as well, right? Totally based on their definition itself. Right. So that is basically one of the examples. Now, as I told you, we collected the data from Indeed, from Glassdoor, from LinkedIn reviews, right? So these are different platforms, and from the survey data as well. So you have to actually find out what data is needed, and then you actually get that. So that first process is called data collections, or gathering the data from various sources such as databases, APIs, and all of that. And the next step is basically cleaning your data, right? Cleaning your data is basically removing inconsistencies, missing values, and outliers if there is any. For example, uh, there is an age column in your data. Let's say you got a database and there is an age column. And in the age column, you see a value such as 500. That is a classic case of outlier. So you have to get rid of these kind of values, right? So most of the time, I mean, you will find that there will be already checks in places applied. You will not get the kind of data set, but you will have to examine your data. And I mean, most of the time, you'll get missing values. So how to deal with the missing values? You can actually go ahead with that. There are various ways to either delete that particular row, or you can also fill that row, right? That maybe we'll see later on. So, and we also use artificial intelligence to actually fill that, right? So this is another use case of AI in data analytics. So um, let's say there is an age column, and the age column is basically, just give me 1 second. All right, my bad. Okay, great. Let's start with this. Let's back to our topic. There was some problem. Okay, so we have data cleaning, right? So as I told you, missing value, I mean, handling the missing value can be one of the data cleaning step, and where we can utilize the artificial intelligence to actually fill that. So we can use ML models to fill that. There are some ML models. So we can use the ML models to fill that value, or we can also use some statistical model. We can simply, let's say there is an age and there is some missing value in the age. We can simply fill it by the mean value of that particular column, or we can utilize other columns, use statistical methods, statistical formula to fill that, or we can utilize, the best way is to actually use the other machine learning model to take other features as consideration and fill the other values. So this is called imputation. So you will get, in the library, you will get various imputation methods, right? Anyways, so as I told you, first step is the data collection, and the next step is data cleaning, removing inconsistencies, missing values, outliers, and all of that. And then the real thing starts, that is called data analysis. Now, data analysis, we can do data analytics. Now, data analysis can be done, through various steps, right? So data analysis is basically, one second. Okay, so data analysis is basically involved applying the statistical and computational technique to extract the insight or to answer the business question. So apply statistics, comma AI/ML, right? Uh, or anything else, right? Apply statistics, AI/ML to actually answer the business question. To answer business questions, right? So what is answering the business questions means? You're trying to answer what the question was. So if I tell you the example of the previous one that I just took from my previous project, so their question was why employees are leaving them, why the churning rate. I mean, I would say attrition rate was very high, right? Attrition rate was very high. So the reason behind that attrition was based on that analysis, whatever that comes out, you can actually tell them, right? So that is apply statistical models, probabilities, AI/ML to actually answer the business question. That is called analysis. And to present your analysis, you can also use the data visualizations as well, right? To present your analysis, let's say you have got to the numbers, but actually visuals appeal much more to the people, to the users, to the stakeholders, right? Just other than just showing the numbers, right? Because human mind process the data, I mean, visuals much more faster as compared to the simple numbers, raw numbers, right? So presenting the data in the graphical formats, such as charts, dashboards, will actually give them better understanding of the data. Now, the important thing here that um, I mean, the data analysis will enable your organizations to make data-driven decisions, optimize the operations, performance, get the competitive edge, and try to understand what are the pain points, right? So that you can eliminate them, you can solve them later on, right? As people say, data is the new oil because data set is required not just in data analysis, but also in the machine learning and artificial intelligence as well. And most of the analysis, if you combine the data science and analytics, that is called data science. And now this is where I was coming into. So we have already seen artificial intelligence. We have seen what are these machine learning, what is the deep learning, right? And what is analytics? What is data science? Data science basically combination of where you combine data analysis with machine learning or AI. That we can call it a data science, right? Okay. So now the intersection of AI and data analytics. This is where we are. Our focus is into. So how enhances your data? How AI enhances your data analytics? How AI can enhance your data analytics, right? So uh, it will reduce, so most of the time it will reduce the manual efforts into data cleaning, pre-processing, and reporting, right? Um, it can help you in pattern recognition. It can help you in, you know, better, it can help you in better uh, data cleaning. Actually, it can help in all the steps, right? Now, uh, data mining. So let's say if you have unstructured data, right? So first thing in data cleaning, in data collection step, let's see how DA can, I mean, AI can have, do the things in data collection step, right? How AI can help in the data collection step. So for example, you have unstructured data, right? If you have unstructured data, such as simple text, unstructured simple text, right? You have, let's say, images, images with tables and text. So what you can do, you can use AI, that's called optical character recognition, OCR. This is not the name of AI, this is the name of a technique. You can use OCR to actually extract the text out of the images, right? And if it has table, already that is a structured data, right? If you have a simple text, unstructured text, right? And if you have to convert into a structured format, say JSON format, or a nested dictionary. Basically, JSON is nothing but the nested dictionary itself. Um, or let's say tabular format, data frame format. So you can actually pass this data into AI. I mean, basically, right away, Chat GPT or even these APIs can actually do these tasks. So in our previous sessions, we have already seen how to use them, how to actually query them with the help of Python. How can you use the APIs, right, with the help of Python. So that is something that we have already seen. Okay, so that you can use to convert your simple unstructured data into the structured data. Right? You can use AI to convert the unstructured data into the structured one. Now, sorry. The next thing is data cleaning. Now, I told you data cleaning involves multiple steps. First one is basically removing the outlier. Okay, removing the outlier can have uh, the rule-based methods as well. Just like you can limit someone's age, say by let's say limit the age between 0 to 100. But what if there can be some real cases with where people can have more than 100 age, 100, the age can be more than 100 as well. There is possibility. There are people who has lived more than 100 years. But if there are a lot of wrong data as well in that case, let's say you raise the bar from 100 to 120, and you got that there are literally a lot of people. You cannot support that data decision with the help of that. There could be some people, but not a lot of people with that more than 100 of age. So there comes, you know, there are some statistical method as well, but they do not work as good as the AI works here. So you will take consideration all the other columns and then with the age column and see if there is any pattern matching. If the pattern is matching, then you can keep that 100. Otherwise, you can reduce that, or you can actually, deal however you want. If you want to discard that, delete that, drop that, however you want, you can use that. Right. So this is where we can also use a data clean, the artificial intelligence, the power of machine learning and AI into data cleaning. Right. First one is basically what? Data cleaning, handling the outliers with the help of AI. Now you can also add the missing values with AI, and you can add the missing values with AI, right? So you can use other columns to predict the value in that particular column to actually fill that. There are KNN imputation, and there are some bunch of other imputation methods which actually use machine learning models to predict the values and fill them together with the artificial intelligence, right? Okay. So that is another thing that you can do in the step of data analytics, right? Now, what's the next step is analyzing the data. So most of the time, you see, if you're doing statistical or probabilistic analysis, statistical or probabilistic analysis, where simply you're creating pivot tables, or let's say you're doing simple group buys, taking the mean, and doing all of these things. This can be done with simple statistical methods, simple tools. But if you require some analysis, are also done on predictive modeling as well. So you can use predictive modeling. You can use predictive modeling in the data analysis as well, right? Where you actually want to create, where you want to actually do the analysis, but with the help of AI, with the help of predictive. So if I go back to our example where I was actually giving them the score. So we have the data, people are leaving. So we have the problem of attrition, right? We have the data, the review data, and we have a framework to calculate a score. And we have, let's say, the pillar of, let's say, innovation, learning, management. So, and similarly, there can be, agility, innovation, learning, management. There could be some other pillars as well. And then, based on the data, what I will do is I will predict if my, based on the I will predict you know, if my comment belongs to which of these category, right? So some people will complain about learning, some people will complain about management, the bad management, worse management, and all of that. People will say that the company do not have any vision, any innovation, and all of that, right? And that's why for better future, they are actually going to the other companies. And then it will be categorized into this. So that happens with the help of AI itself in the first place. And then we actually measure if that, let's say, if a comment comes over here, let's say 300 people are talking about innovation, and out of them, let's say uh, 250 people are saying that there is no innovation. I would say bad sentiment. Right? This is where sentiment analysis comes into the place. So you will use AI to get the sentiment of the review, right? So if I just put it in a perspective, so let's say um, 250 people has negative sentiment and 50 people has positive sentiment, right? So in this case, you will you can calculate a score, you know, and then your each individual scores will have. So we are using not just the simple statistical formulas to actually calculate the score. Now there can be positive rate, negative rate. You can calculate over here, right? Simple. Negative rate you can calculate the 250 by 300. Positive rate is 50 by 300, like that. Similarly, here as well. These are the simple statistical method that we are applying. But before that, we have used AI, to do the analysis, to do the predictive analysis before that. So this is where we can also do the predictive modeling before the analyzing our data. If we need some inputs like that, we can do the predictive analytics, predictive modeling, and then we can use that input into our statistical or probabilistic model to actually say that. Now, these individuals will get particular score. Let's say management gets 1.3. That means that is a very bad management. And before that, let's not 1.3. Let's call it in the range of 0 and 1. In the range of 0 and 1, management got 0.13. This is a really good, really bad management, right? So we can tell that your management is not good. Try to train them, right? Try to train them about management. So if the higher management is not good, they are putting pressures, they are putting unrealistic deadlines and everything. Then we can actually give them some keywords as well. What was the actual problem? What was that? They were not well recognized. They are not, so these things will come into the reviews actually. So we can pick the top keywords out of them. Let's say not recognition. Recognition could be one thing, that they are not recognized. They are doing the task, but they are not actually being recognized. They are not, or let's say sometimes low salary, kind of these things can come into the analysis, and then you can report that analysis to them, saying that this is the problem and this is how you can solve that. You can train the management, you can train the managers to actually um, how to interact with the employees, how not to interact with the employees. You can raise the salaries of the top performers, run campaigns such as this employer of the month, sorry, employee of the month is one of the initiative to actually encourage people, those who are doing good works, to encourage them. So this is one of the very good live example to tackle a problem and how to solve that. What about data manipulation in Alter Studio? So data manipulations is basically, see, in that case, you will see that the AI does the recommendations. I'm coming to that place as well. AI do a lot of recommendations in the data. So let's say if you're leading to a particular analysis, when you feed the data, AI will give you a lot of um, recommendations based on your data itself. So if you go enable your Copilot in your Power BI, or in your Altair, or in your uh, any other BI tools, so you will see that the AI is going to guide you, kind of that. So you will just give the data and the AI will guide you. If you are a newbie itself, so it will help individuals, it will help new learners to actually learn the using the tool, right? If you don't know how to do that, uh, there is also something called query GPT as well. There's a new thing that has been come from that has come from Uber. Uber has recently built query GPT, right? I have not in-depth understanding of how they have built, whether they have built their own LLM or they have built on top of the existing available large language models such as ChatGPT, GPT-4, 4o, or whatever. I've not actually learned into that, but the query GPT is something where you can give the analysis, let's say give the data and give your problem. It will try to do the analysis within the data. So, I mean, query means, let's say you have databases and you want to know that what is the median salary of, let's say, females living in northern region, right? So it will write a query for this. Select star or select group I, all of that. It will do that, and then it will give you one value. That will be the mean salary of women's from the northern region, like that. So you can see AI is writing the analytics query to answer the business question. This is another advanced version of using artificial intelligence in analytics, and we have bunch of other different tools that can actually, you know, uh, we are using a lot of different tools that can actually guide you to your analysis. You can actually use ChatGPT, DeepSeek, a lot of different tools. uh, you can also upload them the data. You can tell them using prompt engineering. There has been immense amount of, we have already actually talked about prompt engineering. What is prompt engineering? What are the different ways to give the prompts? Actually, we have already talked about that in our previous webinars, in our previous master classes. Um, and not just master classes, we at Accelerator X have our current ongoing courses as well, where we actually talk about all of these things in depth, making you guys understand the analytic steps, how to use artificial intelligence in AI, how to use prompt engineering efficiently, how to write prompts efficiently. Not just this, we talk about data science, data analytics, artificial intelligence, machine learning, everything in depth while going into the very deeper, or I would say, uh, not deeper, but I would say, on the lowest level of granularity, right? So that even a simple person can also understand, right? Even a newbie, even someone who is starting his career, let's say you are pivoting your career, if you're a student, you don't know much about it, even a new person can also start understanding from there. So we build from the very ground level, and then we start actually you know we start the foundation from the very ground level actually. All right. So that is what we call, so this is where we can use the artificial intelligence uh into this, right? Uh all right. So we have seen data analytics and visualizations as well. We can also, do visualizations as well of the now AI can help you to, generate what kind of visuals you want for a particular data. Right. So um So automation can be one of the use case of AI in analytics, pattern recognition, predictive insights, real-time analysis. These could be one of the use cases of using artificial intelligence in analysis, right? Example could be, let's say, fraud detection. Fraud detection is can be done with the help of machine learning, right? With the help of AI. Fraud detection can be done with the help of ML, which is a type of artificial intelligence, and this is also kind of analysis, right? Customer segmentation, demand forecasting. These are different examples of using AI in the analytics, right? So it's kind of, when you integrate artificial intelligence in analytics, that becomes data science. And we as Accelerator X has the best courses of data science, uh, which you can actually talk to our advisors, and they will basically guide you to what course to join and all of that. Okay, let's come back. So there are some key AI techniques or data analytics that we can use. Um, First of them is basically, machine learning, right? So we have machine learning, three types of machine learning. We have supervised, unsupervised. So, let's say you have to do segmentations, customer segmentations. So there we use unsupervised machine learning algorithm. And then we have reinforcement learning. So supervised learning is basically model that is trained on the label data. So let's say predicting the house prices, that is an example of regression. Or let's say predicting a student's grade in upcoming exam, that is kind of a classification. So this classification and regression task can be thought of as supervised, or supervised can be categorized into, classification and regression. That is part of actually a supervised machine learning model. Right? So don't think that this is not a hardcore machine learning or hardcore AI stuff. Actually, these are all involved in the embedded inside the data analytics, actually, that we call a data science. Data science is a booming field. That is because we are using AI in the analytics. And when you use AI, when you use machine learning in the analytics, that is called data science, right? Now, classification is one of the example where we predict. It's kind of a predictive analytics. Supervised learning, it's predictive analytics, and where we predict uh, categories. Let's say we have images of different fruits, apple, oranges, and banana. So, or not that. Let's say digit recognition could be one of the AI. Let's say in OCR, in optical character recognitions, where you extract the text out of a picture. That text is called OCR. And there, let's say I'm not talking about all the other things, but I'm talking about numbers. How do we extract numbers? So in the image, we will have small numbers. Let's say we have 4 written as a number, right? So categorizing one image into list of 10 categories. What are 10 categories? An image can be either 0, 1, 2, 3, up to 9. So an image can be either 1, 2, 3, 4, up to 9, from 0 to 9. It could be literally any value. So categorizing an image of handwritten digits into a category of 9, that is called a classification task. This is the category, right? So this is a classification task. But if I say that I am predicting the price of a house or a price of a used smartphone or a used car, like that, right? So that is a regression task, because the value can be literally from a range to another, and it can be literally any value in between, right? So for example, in this case, I'm not predicting 1.2, 1.3 or something like that. I will predict only either 0 or 1 or 2 or 3 up to 9 values. I'm not predicting anything continuous here. But if the prediction is continuous, that is called regression model, right? So regression model will always give you continuous results, continuous numerical values, and the classification model will give you the categories, and the categories can be numerical categories like this, or it can also be non-numerical categories, such as apple, oranges, banana, like this. These are not numerical categories, right? So that is supervised learning here. Now, unsupervised learning, we can simply do, in unsupervised learning, we can do, let's say, clustering, or we can also say segmentation. So segmentation is one of the tasks where we actually segment, let's say, customer segmentation, right? So we group certain type of customers into one segment, right? Uh, let's say if I have if I'm having a store, and if I have a bunch of data, and my target is to, let's say, categorize my customers into 2 groups. One of them that has high paying customers, or I would say, let's say, quality customers. So those who do not worry about price, they just worry about quality. And then the other other group is actually value for money customers, right? So if they have to pay, let's say, 100 rupees or 1000 rupee extra for a better quality, they will do that. But here, these people will not spend extra until the value is compensated well, right? So there are people who cares about value. There are people who cares about quality. So it's kind of there will be 2 category, right? So I'm categorizing. So these people, I can target them differently with different kind of products, and these people I can target them differently with the different kinds of value-based products, right? So this is called a customer segmentations or customer clusterings. We can call it under the unsupervised learning, right? Reinforcement learning is just another method where we actually make the data learn, make the data train um, with the help of doing it. Right. So far, models learn by interacting with the environment, such as optimization of the supply chain logistics. Right. And deep learning can be used. So I mean, we can use deep learning to implement all of these algorithms. Right. Computer vision is one of the subtasks where we actually solve the vision related problems, right? Natural language is basically the part of AI. So let's call about NLP and CV. NLP is basically natural language processing, which tries to solve the text-related problem. Computer vision is basically on vision data. Vision data means images, videos. So if I talk about self-driving car, they are actually solving a computer vision related problem, right? Because they see based on the camera, right? Based on the radars, and then they will try to, drive the car efficiently, avoiding the obstacle, avoiding hitting any pedestrians or humans based on on their way forward, right? So these are the different other, we can say the categories of this. So we can, as I told you, we just talked about how can we use data processing with the AI. We can use the machine value, impute the record with the artificial intelligence. We can put the outliers. We can, have the consistent data formats with the help of AI. We have unstructured data. We can convert them into the structured data, right? We can use feature engineering to create new features with the help of ML algorithms as well. Anomaly detection, automated data cleaning tools like there are data robot. These are the automated data cleaning that use AI to actually clean your data and transform your data. Right? All right. So this is about how can you use and what are the different use cases of artificial intelligence in the basically data analytics spaces, right? So we also have something called, let's say, data science pipeline. So data science pipeline actually starts from data mining or data collection, I would say. And then we have pre-processing, EDA and pre-processing. Actually, we will do some pre-processing and then EDA. EDA is basically nothing but exploratory data analysis. Exploratory data analysis, where you analyze your data to understand about it. And then you go to the ML modeling. Right? Now, once you have created the ML model, then you can actually create to the evaluation of it. Evaluation of the model. And then you can go ahead for the deployment. All right, let's go ahead and understand each step one by one. So you've got the data, right? You have got the data. As I told you most of the time, how to get the data, and most of the time you will get the data ready. Then you will pre-process your data, removing inconsistencies, outliers, missing values, and everything. And most of the time, EDA and pre-processing are done in intervals. It's not like just you will do the pre-processing, then you will do the EDA, but it's kind of a circular thing. And then after that, when you have EDA, we do it to understand the data very, very well. We have to understand our data very, very well so that the model that we are going to create becomes efficient, becomes good, right? And then once we have created the model based on the task that we have been given, right? Let's say predictive analytics tasks, we have to predict the let's say the store sales, right? So based on that, we will do the evaluation, how good our prediction is, right? So for a regression task, we have different matrices. For classification tasks, we have different matrices. So we are going to actually talk about different evaluation matrices based on the task that we have been given. And it's not one way again. So here is going to be again circular way. So we are going to do machine learning and then evaluation, then ML modeling again, then evaluation. And this is going to be in a loop. So you will be doing modeling, evaluation multiple times until you are satisfied with the evaluation, then you can go with the deployment. Deployment is basically making your model available for public uses for anyone to use it. You can build websites, you can build web applications or applications or softwares so that people can download it, people can use it, people can access it with the help of the website or anywhere else. Okay, so that we can think of as the deployment. So this is the proper data science pipeline where we do not have just the analytics as well, but the machine learning modeling, predictive analytics, everything in here in just one go. Okay, does this make sense? Any questions so far from anyone? All right. So this is about understanding the uses of artificial intelligence in the analytics space, right? So let's have a quick recap of it. We actually talked about what is artificial intelligence, what's different classifications, categorizations of it, and then we actually saw, you know, different keywords. How do we actually understand? Um, the AI, the deep learning, the machine learning, the data engineering, right? All of that. Okay, and then we actually talked about the very basic understanding of what is machine learning, the black box analogy, and and then uh, how do machine learn exactly, right? Then we saw what are the different analytic steps, right? Such as data collection, data mining, and data cleaning, data analysis, data visualizations, and all of that. Um, and then we saw that how can we actually you know how can we use the artificial intelligence in each of these analytic steps, right? So we saw that in the unstructured data, if you have in data collection process, if you have unstructured data such as simple text or images with tables and all of that, then how can you actually convert that into the structured data? This is where we can use is OCR or simple LLMs queries for that to actually convert a simple unstructured data into the structured one, right? And then we have data cleaning. So we can use outlier removal with the AI. We can use the imputation method with the different KNN or other AI related, ML related imputation models. And in the data analytics as well, predictive modeling is a very, very pivotal role, plays a very pivotal role where we actually build the machine learning models with the help of this pipeline, the data science pipeline, and we can build these models to actually do the predictive analysis, to do the predictions, and then based on that predictions we'll be actually reverting back our analysis as well, right? So this was about how you use the AI in each and every steps of this analytics, right? You can use the predictive decision making, predictive analytics for decision making, right? I'll also give you an example of real life a project that I did in Deloitte. So these are the things. I bet if there is no question, then just give me 1 second. All right, guys. So that is it. I will see if there is any question or not. No, don't be sorry for asking this question. So let's see. How do you look emerging trends in computer science like quantum computing, 6G, and advanced networking? This is a really good question, and I think that these are this is kind of to be honest, this is where the real effort is going to be. If you see most of these service-based companies, the services that they are offering, they are going to going to be obsolete in some days with the um, people using AI are doing the work of 10 people alone. Like single person can do the work of 10 people using an artificial intelligence if they know how to use that efficiently, right? But if you talk about these, emerging trends, I would not say emerging trends, but the continuous development, right? So you have 1G, 2G, 3G, 5G, 4G, and all that. And then we have 6G, the next one, right? And so these things, as the research and advancements happens, right? Um, as the research and advancement happens in this particular field, so people will be required to do the research. Yes, Naman, I'm going to come to the questions. Right, people will be needed. So this is where the real workforce is going to be, and obviously not this much this amount of workforce required over there. There are only few people who can do research and advancements who has so for example, to develop a modem that can support 6G band, this is where the PhD students, the master students, from IITs and ITs actually go into, into Intel, into AMD companies like this, those who develop actual hardwares. So this will never go obsolete for sure. This will never go out of fashion, these emerging techs. But for that, you will have to be prepared to actually understand that and to work on that. This is going to be the absolute norm. So you see, and if you do not upgrade yourself, you're going to be obsolete and you'll be going to replaced, by someone other who is actually consistently improving themselves. Prompt engineering, actually, we had done quite a workshop, I think a couple of days back on prompt engineering. Not sure what about prompt engineering, what's that question? But I would like to understand, like, I understand what you're trying to say is prompt engineering is a really good way to get maximum out of any AI, any large language models. So if you are, going to take help from, let's say you are in a job or you are in a position that you take help from artificial intelligence from a large language model such as ChatGPT, DeepSeek, or Quen, Gork, or any other models, Llama models, Gemini models, and all of that. So you need to write a good prompt. You need to write a good prompt to get the best results out of that. There are few things that you need to take care of. There are few things that you should be aware of the way to write that. Um, so that you can actually use AI use prompt engineering to actually get the results. So I'll not go deeper. Basically, we had a separate 2 hour sessions on prompt engineering in a couple of days back. So that was another thing. Is data analysis is good field to pursue for the future? I would say, um, I would say kind of a mixed solution. So right now you can do that, but the people working here will significantly reduce as because they are able to use AI in their work. So for example, um, at the 10 years back, there were 10 people required to do a certain task. Now today, one person with the help of AI can do a work of 5 people, right? So where 10 people were required, now only 1 or 2 people can do the job, right? So that job is never going to go, but the efficiency or the productivity of a single person will increase. If similarly, the market is also going to increase, maybe you will see some lesser, people coming into this field, but definitely there is going to be, with the help of AI, there is going to be definitely a hit. So my suggestion is to continuously upgrade yourself on new things so that you never go, out of fashion. All right. Okay, I guess that's it for this session, guys. If you have still any questions left, you can let me know. What skills should we have apart from Python, DS, would you have for the market, like one standout? I would say right now, like learning and understanding LLM. But if you understand, you can only understand LLMs if you are really good at machine learning and data science, other stuff. Just learn about the basic machine learning, and then only you can be really good at LLMs. LLMs are, going to be really big things in upcoming time. So you can build the solutions based on the large language models, right? And those solutions, people can use it. You can really build some, you know, use cases with the help of large language models. That will be a really good thing to do. Certificates, if you have filled the form, you guys will get the certificates in 24 hours. You can search my name, Akash Maurya, LinkedIn. You will get, most probably the first link will be my LinkedIn profile. You can search, see I've worked in Nagaro and Deloitte and Cognizant as well. Yeah. Yes, we can end the class. That's it for today. Thank you so much, guys. This was really nice talking to you. And I really enjoyed interactive sessions when you guys ask the questions and I have to answer that. I really love these kind of sessions. So that is it. Thank you so much, guys. Maybe next times we will see you guys into some other webinars. Do follow, Accelerator X on your on all the platforms on LinkedIn, on other social media platforms. There we post all the requirements and upcoming webinars. So to actually upgrade yourself. That's it. Thank you so much, guys. We'll see you in the next one. Till then, bye bye. Have a great day.